wabarakatuh. Hello, my name is Muhammad Dizoilmi bin Rosali. I am a UTM student of Bachelor in Engineering Technology, Robotic and Automation. First of all, I would like to thank you to Encik Muhammad Rosali bin Muhammad Safi'i as my panel 1 and Encik Muhammad Farid bin Ibrahim as panel 2, and also my supervisor Encik Arman Hadi bin Azhar and my co-supervisor Puan Rahaina binti Jaafar. And I also would like to thank you to my beloved father Encik Rosali bin Abdullah and my mother Tengku Noraini binti Tengku Abdullah. The introduction of my project is the automated robot for area mapping is a development of assistive measurement and mapping device that will change the traditional way of measuring length or distance and area. The accuracy and precision of the robot sensor will be analyzed to make the automated robot for area mapping is robust and reliable. First, there are two devices used for measuring the length. First device is the measuring tape and the second is the laser tape measure. And why did I come up with this idea? This is because the limitation of using measuring tape, where it is only 100 feet up for measuring only, and the second is it is difficult while measuring the area that is not in straight line. And for the laser tape measure, the problem is the user needs steady hand to make the measuring more accurate while taking measurement. The objective of my project is to develop an assistive mapping device, and the second is to evaluate the measurement performance of the device. The scope of the automated area mapping project is the design of the project that will automatically measure the area in a room or any space of building construction. Besides, the device also can store and record the measurement data for future reference in case of any losses of documentation. The flowchart of the project of automated robot for area mapping is when you on the supply, it will power the LCD display showing the initialization of the project, and it will scan the present of the SD card. If the SD card is not present, the project will not start up. If the SD card is present, the project will go following the wall, measuring the left side distance, because the sensor is placed, the ultrasonic sensor is placed at the left side of the robot, and it will measure and powering the encoder at the bottom of the project. While following the wall at the left side, it will taking the data of measurement and place or store it in the SD card. For the hardware part of the automated robot for area mapping, I use as the brain of the robot is the Arduino Mega 2560, and for the sensor, I use the HRSC04 ultrasonic sensor at the left side and at the front of the robot. For the battery, I use lithium ion 3.7 volt, two pieces of them attached at the back of the robot. For the measuring the distance traveled by the robot, I use the encoder sensor module attached at the bottom of the robot, aligned properly with the grip plate. This chassis is made of aluminium and equipped with 65 mm of diameter. For the display, I use 16x2 with I2C module attached here at the side, so the display will show the measuring or distance traveled by the robot. first thing first is the comparison effect of good and poor placement of the ultrasonic sensor and the robot. The analysis that I get in the graph, it shows the illustration of the movement of the project. I test it out at a 180 cm wall of length and test it out with different placement of ultrasonic sensor. I set it in the coding for the side wall distance for left side is 10 cm. I set it to 10 cm because the center rotation of wheel of the robot and the ultrasonic sensor at the left side is 10 cm. That's why I set it in the coding to 10 cm for the robot, for the automated robot for area mapping for easy turning when it detects the front obstacle or front wall. The next graph is the ultrasonic HRSC04 reading for 1 round following the auto box. As you can see, the plotted graph is the left for the left side ultrasonic sensor only. It shows or illustrates the movement of the ultrasonic. The 999 cm shows the reading of the ultrasonic when it turns. It shows the turning point or when the robot do not detect the wall at all. That's why it's 999 cm. I set it in the coding as a written value for the ultrasonic. The plotted graph then illustrated to map around the outer box. As you can see in the figure below the plot graph, the graph is illustrated to show the movement of the automated robot for area mapping around the outer box. Thus, the mapping can be achieved. Next is the bar graph of average result of encoder sensor module calibration. The test of the calibration of the sensor is made 10 times and the average is 23.82531 cm or displacement. And for the reference displacement for one rotation of 65 mm diameter of wheel is only 20.8 and the offset error gives a 3.02531 cm of displacement. The actual perimeter of the outer box is 403.86 cm. The automated robot for area mapping measure it and the displacement of the robot is 497.7904 of displacement, giving out the difference of 93.9304 and resulting 23.25% of error. In order to make this project come real, this is the reference that I used to. The development of automated robot for area mapping that automatically measure the area of room or any space is successfully fulfilled and objectives are achieved. Besides, the device also can store and record the measurement data for future reference in case of any losses of documentation. The drawback of the project in terms of measurement performance, the calculation for calculating the displacement or distance traveled by the robot produce an offset error which the distance or per pass should be 1.04 cm, but the project the sensor get 1.19 cm for per pass, where the average value of displacement for one rotation of wheel divided with 20 number of holes of the grip plate. The hardware and coding development need to be improvised more in order to enhance the precision and accuracy of the robot.
Next, we go to the demonstration of the automated robot for area mapping.
Hadi bin Muhammad Safi'i and Encik Farid bin Ibrahim as panel 2, and to my supervisor Encik Arman Hadi bin Azhar, and also my co-supervisor Puan Rahaina binti Jaafar for guiding me from the start until the end of the PDP 2 project. Thank you so much. Stay safe, stay home.